Nope. Okay. So, boys and girls, good morning and welcome to the first of 3 videos on section 1.5 in chapter 1, which is entitled Analyzing Graphs of Functions. All right. So, as you probably remember from your high school math days, graphing is an exceptionally important aspect to arithmetic, algebra, geometry, and precalculus. So, it's important that we know that when we have a function, or even if we don't have a function, that we know how to graph it and what its graph looks like. And so in this chapter, we're going to spend a bit of time just going through how to graph certain relationships and also how to interpret graphs that we are given and how to glean information from them. All right, so what exactly is the graph of a function? Well, it's defined as the collection of ordered pairs x, f of x. And remember that back in the day, we used to refer to this as x and y. So this may be a more familiar way of seeing what an ordered pair is written like, such that x represents the domain of f, all right, f being the function. The value of x is the directed distance from the y-axis. And if you look at a Cartesian coordinate system, the y is the vertical line, of course, and the x is the horizontal line here. And so x is the distance from the y-axis. So in other words, the value of x is how far I am from y. So y, 1, 2, 3, 4, 5, and so on. Okay, and y, whoopsie daisy, y or f of x is the distance from the x-axis. So here's the x-axis, 1, 2, 3, 4, or of course we can also do either of these in the negative direction. Okay, so the graph of the function is simply defined as the collection of ordered pairs x, f of x, such that x is the domain of f. And x, of course, is the distance from the y-axis, and the y value, or the f of x value, is the distance from the x-axis. All right, so let's have a look at an example of a graph. Now, this is a graph that probably does not have an algebraic formula associated with it, but will, for the sake of argument, refer to this thing as y equals f of x, all right? If you can find a formula that matches this, God bless you, all right? But example 1 asks you to use the graph of the function f to find a, the domain of f, b, the function values f of -1 and f of 2, and finally the range of f. Now all of these things are actually illustrated right here on the graph itself. The domain of f, of course, is all of the values of x that have a value of y in this graph. And so if you look from the leftmost portion of the graph right here, all right, this is at a value of x equals -1, and the graph goes all the way over to here at x equals 5. And so the domain of f in this case is going to be -1 all the way to 5. Now, the one thing I do want you to notice about the way I wrote this is that the -1 is encompassed by a bracket. Okay, and what that indicates is that -1 is part of the range. In other words, the value x equals -1 is a value, I'm sorry, not the range, the domain. All right, so -1 is a value in the domain of f. 5, on the other hand, if you look carefully at this point right here, notice that it's indicated with an open circle. And what that suggests is that the point 5, comma 2 is not part of the domain of this function. Okay. Now, what are the function values of f of negative 1 and f of 2? Well, if x is equal to negative 1, then y is equal to 1. Okay, so f of negative 1 equals 1. Okay, easy peasy. How about f of 2? Well, if we go to 2, here's x equals 2, follow it down to the point and go across to the y-axis. That looks like negative 3 to me. And so f of 2 is going to equal negative 3. Okay. And finally, the range here, all right, well, if we start at the lowest value here, the lowest point has a value of y equals negative 3. The highest value has a value of y equals positive 3. And so, and both of these numbers are included, gosh darn it, included in the range. And so I'm going to put both of them in brackets. So negative 3, 3. So this is the range. This is the domain. Okay? And so that's how we can use a graph to determine these kinds of pieces of information. All right? All right. Now, the vertical line test is one of the things that most students are already aware of. It seems to be one of the things that they're most enamored with when they get to a course in Precalculus. And the vertical line test really goes back to what we were talking about in Tuesday's video on what makes a function a function. All right. Well, a function means, if something is a function, it means that each value of x can have one and only one value of y, meaning that any place along the function that you draw a vertical line, it will only touch the function once. Okay, and so what we can do here is use the vertical line as a test to determine whether a certain mathematical relationship is indeed a function. Okay, if you draw a vertical line and it touches the graph not at all, then it might be a function. If it touches it only once, then it probably is a function. But if it can touch it more than once in any of these, in any scenario, at any position, then the relationship is not a function. Okay, so the vertical line test is that if a graph in the xy plane defines a function, or defines y rather as a function of x, if and only if no vertical line intersects the graph in more than one point, or at more than one point. All right, and so how would you go about looking at something like this? Well, let's have a look at example number 2. Let me get my ugly mug out of the way here. But let's have a look at example number 2, and it says use the vertical line test to decide whether each of the following graphs represents y as a function of x. Okay, so obviously in graph A, all right, I'm actually hitting the relation at this point and at this point. All right, and so the vertical line crosses the relationship twice at this point. As a matter of fact, I could draw this here or here or here, and it doesn't matter where I draw it on this particular relationship. I'm going to find out that it hits the graph more than once. And so this means that the graph A is not a function. Now, in graph B, on the other hand, I've got a scenario where the vertical line only crosses the relation once, and it doesn't matter if I draw it here or here or here, all right? And I know those lines aren't perfectly vertical, but you can pretend for a minute. No matter where I draw the vertical line, it only crosses the relation once, and therefore this relation is a function. Now, the third one is interesting because no matter where I draw the vertical line, I will cross the relation once and only once, okay? But between x equals 0 and x equals 2 in this range right in here, I don't actually strike the relation at all right? The vertical line doesn't come into contact with it at all. This is okay, all right? Because in this case, all that it means is that at x equals 1, for example, the relation is undefined. That doesn't make it a non-function. It's still a function, okay? It just means that between x equals 1, or no, I'm sorry, x equals 0 and x equals 2, that this relation is, that any value of x there is undefined, all right? But it is still a function, okay? It's still a function. Okay. Now, zeros of a function can also be determined using a graph, all right? And as we talked about in the previous section, we know that the zeros of a function are simply the values of x for which f of x equals 0. So in other words, this is the point where the graph crosses the x-axis, right? Because if you look at a graph, here we go, okay? Where is the value of y 0? Well, it's 0 where we cross the x-axis. So y is equal to 0 right there, and y is equal to 0 right there, right? Because the x-axis is y equals 0. Okay? So the x-axis is y equals 0. And so if we simply set the function equal to 0, we can calculate what those values of x actually are. So in example number 3, I'm going to ask you to find the zeros of each of these 3 functions, okay? Actually, they're not all functions. The second one, b, is not a function, but that's okay. F of x equals 3x squared plus x minus 10. G of x equals the square root of the quantity 10 minus x squared. And finally, h of t equals the quantity 2t minus 3 divided by the quantity t plus 5. All right, so we've got 3 different examples here. And in each of the next 3 slides, I'm going to actually graph this function. Now, for those of you who don't have graphing calculators, I'm going to send you to a website called graphsketch.com. That's an H. All right, graphsketch.com. This is the program that I actually used to draw the graphs that you see on the screen now. All right, I cut and pasted them into this PowerPoint, but you can use this to draw your graphs. All right, so I highly recommend, if you don't have a graphing calculator, that you go to this website and play around with it a little bit, because it will be quite helpful. Now, so let's get back to what we were talking about here. We've got the function f of x equals 3x squared plus x minus 10. And I know for a fact that this is indeed a function. It passes the vertical line test. And if I look very carefully, I can see that at x equals -2, and x equals some fraction between 1 and 2, I end up with f of x equals 0. So let's do this, shall we? 3x squared plus x minus 10 equals 0. I have to factor this. So I'm going to have 3x here and x here. And I need something that, because 3x times x is 3x squared. Now, I need two factors, one of which that multiplied times 3 plus the other is going to give me positive 1. Okay, my guess is -5 and positive 2, right? Because 3x times 2 is 6x minus 5x is x. All right, so that seems to be reasonable. Now, does that do -5 and 2 multiply to give me -10? You bet your sweet bippy. So that is the correct factoring of this particular problem. Now, if that's the case, then if 3x minus 5 equals 0, then 3x equals 5, and therefore x equals 5/3, which is equivalent to 1.66666. All right, does this look like it could be 1.666 or 5/3? You bet your sweet bippy. All right, absolutely. Now, if x plus 2 equals 0, then of course x simply equals -2. All right, and of course that point right there is indeed x equals -2, 0, or x equals -2. All right, the point is -2, 0. So this is going to be -2, 0, and this one is going to be positive 5/3, 0. All right. All right. So there's the first one. Well, let's have a look at the second one. Now, this is one of the ones that GraphSketch.com can't actually draw. This is actually, if you look at it carefully, the formula for a circle. If you take the square, if you square both sides, it becomes y squared equals this. And if you recognize the x squared and the y squared as a circle, you'll realize that this is, well, it's not really circular, but you get the idea. All right. In any event, this is not a function, okay? Because any vertical line drawn hits the relation rather at two different spots. Now, if you, however, go ahead and try to figure out where it hits the x-axis, then g of x is going to equal the square root of, whoops, I'm sorry, gotta erase that. Oh, come on now. There we go. Back to the pen, and this is going to be 10 minus x squared. If I square both sides, I still get 0 equals 10 minus x squared. Subtract 10 from both sides. Really? So -10 equals -x squared, and therefore x squared equals, I'm sorry, the x rather, let me get rid of that, 10 equals x squared, and x is going to equal the plus or minus the square root of 10. All right. Now, because there's two values of y for each value of x, that means it fails the vertical line test. All right. But if you look at these two numbers, right here is positive the square root of 10, right? The square root of 10 is a little over 3. And here is minus the square root of 10, which is, again, negative 3 point something or other. All right? So those are the 0 points here. Last but not least, this is a function. And so here, I'm going to set the quantity 2t minus 3 equal to blah, 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 0, all right? Because 2t minus 3 over t plus 5 equals 0. Well, how do I get a 0 in a fraction? All right, the denominator can't be 0, because if the denominator is 0, then the number is undefined. So I have to set the numerator equal to 0. So 0 is actually going to equal 2t minus 3. Therefore, 3 equals 2t, and therefore t equals 3/2. All right, now, does this look like 3/2 or 1.5? You bet your sweet bippy. And so that is the zeroing of this particular function. All right, so that's where I'm going to end this very first video. We will pick up with video number 2 in just a couple of minutes.